All right, so common assessment, here we go. So number one, it's asking which value for x makes the number sentence true. All right, so basically all that's saying is just solve for x. So for number one, okay, you got a two-step equation, and remember with your two steps, the first thing you do is you get rid of your addition and subtraction. That's going to be the 10, and then my second step is my multiplication and division. All right, for that one. So all you're doing here is solving for x. Number two, choose the correct solution for the equation. So again, that's just a fancy way of saying, hey, solve this equation. So number two is also a two-step, okay? And the first thing you do is your addition and subtraction, okay? So we get rid of that first, and then your second step, your multiplication and division, all right? So when it says to choose the correct solution, you're basically just solving, okay? Don't let all that stuff kind of get to you there, all right? Number three, solve for x. Okay, so number three is what we went over the other day. This is when you have variables on both sides. All right, so when we have variables on both sides, we need to get the variable to one side. So I think Brendan, you asked a question on that. So here is, I'll give you an example. Let's say I have 7y minus 4 equals 3y. Okay, here's what's confusing, going to confuse you all on this one. Well, I want to get my variable, which means I know I've drilled it in you saying, hey, let's move this to the left. All right, I like having the variable on the left. That's fine. So the opposite of plus is a positive 3 is a negative 3y. And we do to one side, we do to the other side. This is going to be 4y minus 4. Now, 3y minus 3y, yes, they cancel, but the reason I said they cancel is because they equal 0. And we don't just put plus 0 in here. So this is just going to be 0. Okay, and then I have a two-step, and I would just add 4, add 4. You're going to get 4y equals 4, divide by 4, divide by 4, and you would get y equals 1. Okay, so that's kind of like a similar example to number 3 there. I always like want to take my pencil and go over here and point to that question like it's sitting here next to me or something. I don't know. So that's kind of some help on number 3. Now you could take this 3x from this side to this side. You could do that. Okay, that's fine too. And you'll just have the variable on the right, and it'll just make that process a little quicker. Okay. Number 4, what is the solution to the equation? This one again, you have variables on both sides. So for number 4, I would move variable first. Okay, get to one side, and once you do that, then you just have a two-step equation. Okay, so use your two-step rules there for that one. All right, so that would be what you do on number 4. Number 5, okay, number 5 is one of those questions where you'll look at it and you think you're really confused. But if you look at the left side of that equation, all the ends over here, okay, the one thing you want to do on number 5 first is I want to simplify. And for number 5, how do I simplify? I'm combining like terms. So the first thing you do on number 5 is combine like terms. And when I combine like terms there on that one, that's going to get, there's 3 n's here. So it's going to be 3n equals 60 once you combine those. And then you would just solve. Okay. Or if you're really stuck, you can take these answers, A, B, C, and D, and you can plug them in up here and see which one equals that. All right. So for example, let's say that I thought it was 6. Well, all right, so I would do 6 plus 6 plus 6. Well, 6 plus 6 plus 6 is 18. So 18 doesn't equal 60, so it couldn't be that. You could substitute those in and do it that way too. That's another way to do that if you're really, really confused. Okay. Do you have a question? All right, number 6. What value of x makes the equation below true? So number 6 again is just like 1 and 2. All you're doing is solving. Okay, so the first thing I would do in number 6, let's do that distributed property first and get rid of that. Okay, so get rid of your distributed property. So for number 6, it's just 2 times x and then 2 times -5. Remember, when you have your subtraction, don't just bring that subtraction sign down. Okay, use your multiplication to show your operation. It's like positive 2 times -5. That's going to give you -10 there. Okay, so just remember that you do your distributed property first, and then your second step is we're going to combine like terms because we need to simplify that. So, because when you do your distributed property, you're going to have multiple x's there. And once you combine like terms, now you have a two-step equation. And if you remember our two-step rules, right up here, number 1, number 2, give your addition and subtraction, and then your multiplication and division. Okay? Number 7. Number 7 is a special case. Remember those special case equations we talked about. All right? The first thing that we're going to do in number 7, well, that's a terrible little 1 there. So my first step we're going to do in number 7 is I'm going to multiply 3 because we got to get this 3 out of the bottom. Okay? Because if you remember, number 7 is not just, let me write this problem down. Negative 4x minus 2 over 3 equals -6. You're not going to add 2. Remember, this is the same as negative 4x over 3 minus 2 over 3 equals -6. Everything up here is being divided by that. Okay? So before we start anything there, I need to multiply this 3 and get rid of it. All right? So I multiply that 3 to both sides. Once I do that, then you have a two-step equation. Okay? So just same rules apply as we did on number 1 and 2. Because when you multiply that out, you're going to get negative 4x minus 2 equals -18. And then you would go from there and solve. On number 8, which equation has infinitely many solutions? What you're going to do in number 8 is you're basically going to solve those, okay, or simplify them as far as possible. So we're going to simplify each answer to see which equal each other, okay? So remember, with infinite number of solutions, both sides have to equal each other. So example, if we had 3x plus 5 equals 3x plus 5, that would have infinite number of solutions because both sides equal each other. Okay, so that's what you would do on number 8 there. Number 9, you're just telling which statement is true. Okay, so you look at this equation here. All right. My advice on number 9 is to simplify equation first. So simplify that equation first, then determine what is true about that equation, okay? Because if you notice here, they have this in distributed property. So right now, looking at this, you get these parentheses, they don't look the same. You can't really tell a lot about them because you can simplify over here. So simplify this side first and then determine what your answer is there. Number 10, what value of r makes this true? Number 10 is just a one-step equation. So number 10 is just a one-step. And remember, we solve equations, we use inverse operations. And if you don't know how to solve number 10, you can substitute. You can take each one of these answers, and I can substitute those in for r and do that number divided by -11 and see if it equals -3. So you can substitute that in and see which one works, okay, and go from there. It's not cheating, but it's using your resources to the best of your advantage, if that makes sense. Okay, it's like I could put -33 in up here. Well, I know -33 divided by -11 is +3, so it can't be that. Okay, Brian, do you have a question?
No, I don't have a question.
Okay. I said you raised your hand. That's why I was asking.
Yeah, I was just wondering what that button was.
Oh, yeah. It just tells me you raise your hand. It don't even make a noise or anything, which is weird. All right. So number 10 is just a one set. 11, we're just solving for x. Okay. Now for 11, all right. The one thing to remember on 11 is um, cannot have a negative variable. Okay. Number 11 cannot be negative. All right. So 11, you can't have a negative variable. So when you solve 11, okay, I'll get rid of this 54. But the 54, am I going to add or subtract that 54? That's one thing that's going to get you, because do not look at the sign behind it. Whatever's in front. What type of 54 is this? It's a positive. Okay, this is a positive 54. The opposite of positive 54 is negative 54. So you would subtract 54. Okay, that's a question that would get some of you guys, because we would look at this sign behind it. All right. And the rest of it is just review from what we've had in the past. Okay. So basically, all I was going to review is just those top 11 or 12 questions, okay, from equations. All right.